This lecture explains the observations we made of the moon's changing appearance. The learning goals of this video are to be able to explain the change in the size of the lunar disk, the librations, and the phases. A subsequent video explains how to predict moon phases. The moon's orbit is not circular. It has an eccentricity of over 0.05. When it is farthest from Earth, at its apogee point, it appears smaller in the sky than when it's closest to Earth at its perigee point. The moon rotates once on its axis as it orbits the Earth. This is because it is tidally locked. Yet, because of the eccentricity or elliptical nature of the orbit, it appears to rock back and forth, causing east and west librations. The moon's orbit is tilted. The inclination of the moon's orbital plane from the plane of the Earth's orbit is between 5 and 6 degrees. This inclination means that we don't have eclipses every month. It also means that we see more of the northern part of the moon sometimes and more of the southern part of the moon other times, and hence the north-south librations. But being only 5 or 6 degrees from the ecliptic means that the moon's path across the sky as it rises in the east and then sets in the west means that it follows a path very close to the sun's path, the ecliptic. Have you considered what the moon's orbit around the Earth while the Earth orbits the sun looks like? Knowing that angular momentum is conserved as the moon orbits the Earth, draw a sketch of the entire year of the Earth's orbit and the moon around the Earth in orbit. Remember that there are 12 full moon months in a year. Pause the video now and make a quick sketch, and then return and continue. Somewhat to scale, this is what the Earth and Moon orbits look like. From the full moon to full moon, it is about 28 days, about 12 times per year, so the cycle of full moon to full moon subtends about 30 degrees of the 360 degrees of an Earth's orbit around the sun. Here's a quick sketch, not quite to scale, of the Earth's orbit in green and the moon's orbit in purple. To scale, both would appear to be smooth and circular. The moon spins on its axis once per orbit around the Earth. This is called synchronous rotation. The moon shines because of reflected sunlight. Half of the moon is always illuminated by the sun. The phase of the moon is determined by how much of that bright side we see. New moon means the moon between the Earth and the sun, and so we don't get any of the reflected sunlight. A crescent moon means less than half of the moon is lit up from the Earth's point of view. A quarter moon, the moon is at a right angle with the Earth and the sun line. And gibbous means that more than half of the moon is lit up from the Earth's point of view. Full moon on the opposite side of Earth from the sun. From northern hemisphere, this is what the cycle of phases looks like. Rossetti wrote the following poem: O Lady Moon, your horns point toward east, shine be increased. O Lady Moon, your horns point toward west, wane, be at rest. This poem only works for observers in the northern hemisphere. As you can see, the phases of the moon from the southern hemisphere are in the opposite direction of those in the northern hemisphere. And gibbous means a shape that is convex or bulges outward on both sides. So we both go through the cycle of phases from new to waxing crescent to first quarter to waxing gibbous to full to waning gibbous to last quarter to waning crescent. Waxing means growing, waning means shrinking. Crescent is a crescent shape and gibbous is a convex bulging outward shape. But the phases direction of the horns is seen in opposite directions between the northern and southern hemisphere, with the equator being sort of horizontal in its phase. Wiki has a nice diagram showing the cycle of phases along the Earth's orbit. Just as there is a difference between solar days and sidereal days, there is a synodic month and a sidereal month. The synodic month is the amount of time it takes the moon to return to the same position in the sky relative to the sun. That's 29.5 days. The sidereal month is the time it takes for the moon to return to the same position in the sky relative to the stars. That's 27 and a third of a day. In summary, the moon shines because it reflects light from the sun. Half of the moon is in daylight. Phases are due to the changing angle between the sun and the earth and the moon. East-west librations are due to eccentricity of the moon's orbit. North-south librations are due to the tilt of the moon's orbit with respect to the Earth's orbit around the sun. The same face is always pointed toward Earth, and this is called synchronous rotation. The cycle of phases is a synodic month, and it takes 29.5 days.